Okay, all Algebra 10 and Advanced Algebra 10 and Advanced Algebra students, this is what's going to be on your final coming up in a day. There's two parts to the test. The first part here, this chapter 5 has no calculator. That means you get nothing but your pencil and your brain to figure these out. Then once you get that little part done, you will move on to this second part where you get to use your calculator, and then you have to do all of these different things. Now this first video is going to go over most of everything that is on this no calculator part, and then the second video has everything for that part, except there's one question that is on this part, this video. It's going to be on the video that you're watching right now. That is actually part of this one. It's the last question we're going to do. All right, so looking at this, evaluating expressions, simplifying some other things. So here you'd say 5 to what power is equal to 1 over 125. Again, remember you're not getting a calculator on this whatsoever. So now 5 to what is 125? And that would be to the third power, but because these are reciprocals of each other, then that turns this into a negative 3. This one here, ln the square root of e. Another way to write square root is ln of e to the 1/2 power. Square root is 1/2. If this would have been the cubed root and there was a 3 there, then you would have ln e to the 1/3 power. Whatever the root is the denominator of your fractional exponent. And then by your properties of exponents, this 1/2 gets pushed to the front as the multiplier of the logarithm. So now you have 1/2 of ln of e. And remember, ln and e are inverses of each other, so they eliminate each other, and you're left with just 1/2. You'll get a few like that. I mean, there'll be some other ones that'll probably be easier than this one here or that one there, and then maybe there'll be one that'll be a little bit more difficult. But that's generally what you're going to be asked to do without a calculator. Then in Advanced Algebra 10 and Advanced Algebra, you have to simplify some expressions. And here, because you have 3 and 18, that can turn into 1 and 6, because 3 goes into both of those two. You have x to the 4th in the numerator, x squared in the denominator, so these two go away. They take 2 with them and leave 2 there, so then x squared is in the top. The negative exponent means it has to get flipped to the bottom, becomes the reciprocal of it, so then there's already 2 in the bottom and you're pushing 5 more down to it, so that's y to the 7th, and there's your answer. And then finally in this last one, you have 4 and 10, 2 goes into both of those, 2 and 5. Again, negative exponent pushes it down there, there's already 3 there, so it's x to the 7th. This negative 2 gets moved to the numerator, so then that becomes y to the 5th. And you can't do any more with it, so you leave it. All right, then moving on. Here, expanding this. This might even be on the second day, the second part of the test, using your graphing calculator, but you really can't do anything with a graphing calculator with this anyway, so just trying to expand. Because there's multiplication in between these two things, it becomes ln of x squared plus ln of y. And then if you take this, because it has an exponent, it gets moved to the front of it, so it becomes 2 ln of x plus ln of y. And that's the expansion of it. If this would have been a divide sign there, then you would have had 2 ln of x minus ln of y, because division means subtraction. All right, then this one here. It is a longer one, 4 log 3 of x minus 2 log base 3 of 4 plus 3 log base 3 of z. So first off, because there's a multiplier, that gets moved as an exponent. This 2 gets to be the exponent of the 4, and this 3 gets to be the exponent of the z. So now you have log base 3 of x to the fourth minus log base 3 of 4 squared plus log base 3 of z cubed. All right, so then we have log base 3 and x to the fourth, and it's minus 4 squared. Well, 4 squared is 16, so minus 16 means we have to divide by 16 because subtraction means division. Just like here, division means subtraction. And then here we have plus z cubed. Well, because it's plus, it means it's multiplied, so then that would be z to the third in the numerator. This is the only part that is being divided, so then the 16 is the only thing that is in the denominator. Now, if that would have been switched, and let's say it was 4 log base 3 of x minus, and then a parenthesis, 2 log base 3 of 4 plus 3 log base 3 of z. Okay, so now when you do this one, because this is in parentheses, you're dividing this whole thing, so you would have log base 3, that becomes x to the fourth, and then you would have 16z cubed in the denominator because you're going to divide both of those two things because they're grouped together. All right, like I said, that may come on the calculator part. All right, then finding an inverse. Remember, to find an inverse, you just say y equals x squared plus 7 to start with. And now just solve for x. So subtract 7, and y minus 7 equals x squared. Then divide, or take the square root, and x equals the square root of y minus 7, plus and minus. And so then when you write the inverse, because we're writing it as a function, we can only use the positive one, so then it becomes x minus 7. There's your inverse. The other way to do that is when you do this is switch the x and the y, so then you would get x equals y squared plus 7, and then solve for y. And you're still going to get the same thing as this. And since we have to try to find the inverse function, you only can have one answer. All right, then looking at these and evaluating, if you have f of 3, that means you'd put 3 into this function here, so 3 squared plus 7, which is 16. If you have the inverse of 32, that means you have 32 equals x squared plus 7. And then when you subtract 7, you're going to get 25 equals x squared. And then you take the square root, and x could be 5 or negative 5. And then with this one, because you have an inverse and a function, and they're both the same thing, they go away, and you just have 13 left, because inverses get rid of each other. And so now the same thing with this one. You have an inverse and a function, and they just both go away, so then x equals 276. And then that's it for that part. Now, this one comes out of your book. This is problem number 10 on page 296. And there will be a problem like this on the calculator part. It says a new incentive plan for a talk-a-lot long-distance phone company varies the cost of a call according to the formula cost equals A plus B log T, where T represents the time in minutes. When calling long distance, the cost for the first minute is 50 cents. Oh, got that wrong. It's 50 cents. And for 15 minutes, it's $3.44. Find the A value in the equation, find the B value in the equation. And so the first thing you want to do is write a couple of equations. You already know that the first minute is 50 cents. So we know that T is 1 and cost is 50. So you have 0.50 equals A plus B log of 1. Your other equation is 3.44 equals A plus B log 15. Now the first question says find A. Well, if you look at this equation right here, and this is the one you should look at first, because what is log of 1? Using your calculator, I hope you don't need to, it is 0. And 0 times b is still 0. So then a is equal to 0.50. See how that works? So now that we know that a is 0.5, we can bring that over to this equation and put it right there. So 3.44 equals 0.5 plus b log 15. Now if we want to find b, we better solve for it. So we subtract 0.5, and when you subtract those two things, you will get 2.94 equals b log 15. Now the operation in between b and log 15 is multiplication. Understand that log 15 is just a number. And that number is like 1.176091259. Don't really care about that. So we're going to try to solve for b, so we have to divide by log 15 on this side and divide by log 15 on this side. So then we will get b is equal to 2.94 divided by log 15. And that is going to be approximately 2.499806 and change. Now, if you rounded this to, let's say, 3 decimal places, which is right there, this becomes 2.5 is equal to b. So now we know what a and b are, so then we can say cost is now equal to a is 0.5 plus 2.5 log 15. No. Log t. So there we've found a and b. Then it says, what is the x-intercept of the graph of the equation? Well, remember, the x-intercept is when that is 0. Because the y value has to be 0. So if you solve this, you're going to get a negative 0.5 equals 2.55 log t. And then you divide by 2.55. And a negative 0.5 divided by 2.55. Not 2.55, it's just 2.5. You're going to get a negative 0.2 equals t. Is that right? Oh no, not t. It's going to be log t. Log t. And then to solve that, remember this is base down here. If you don't see the number is 10, so it becomes 10 to the negative 0.2 equals t. So 10 to the negative 0.2 is equal to 0.630957 and stuff. So what that means is you can talk for 0.63 minutes without having to spend any money because your cost is still 0 in the context of this problem. Then it says use your equation to predict the cost of a 30-minute call. So then you would have to put a 30 right there. And then take out your handy dandy calculator and 0.5 plus 2.5 log 30. And you are going to get, when at 30, you will get 4.192 and stuff. So that's $sign $4.19. And then it says if you decide you can afford only to make a $2 call, how long can you talk? Well, so then that means you have to put a 2 there. And so then 2 equals 0.5 plus 2.5 log t. All right, then you got to subtract 0.5 and then divide by 2.5 to get log t equals 2 minus 0.5, which is 1.5, divided by 2.5, which is 0.6, equals log t. And again, to get rid of the log, you have to take 10 to the 0.6 will equal t. So 10 to the 0.6 is 3.98 minutes you can talk to make a $2 call. And that is how you do that problem. Look at this again if you need to before you take the test. There is another part of the review, and that goes over more of the other problems that are on this review sheet.